Hello viewers, welcome to Kids Auto and Truck Repair. Today we have a 2017 Jeep Wrangler with a 3.6 liter. The customer complaint on this vehicle is the check engine light remains on the dash while the engine is running. So the first thing we're gonna do is we're gonna start the engine so we can confirm the customer's complaint. After confirming the customer's complaint, we're gonna connect the scan tool to the vehicle so we can figure out why the check engine light is remaining on the dash while the engine is running. So now let's confirm the customer's complaint. So right there, as you can see, the engine is running and the check engine light remained on the dash. So the customer is complaining about this light. So customer's complaint confirmed. I'm gonna turn off the engine. I'm gonna turn the key on. I'm gonna get the scan tool connected to the vehicle and then I'll bring you guys back up. I got the scan tool connected to the vehicle. I'm gonna bring it up. Let's scan the engine computer and see what we got. So right there, the scan tool has identified the vehicle, 2017 Jeep Wrangler with a 3.6 liter. So we're gonna click OK. Let's do a code scan. Let's scan all the control units on the vehicle. The scan tool is done scanning all the control units on the vehicle. We have two trouble codes in the engine computer. The first trouble code is P0365 and it says camshaft position sensor circuit bank 1 sensor 2. And then the second code is P0369 and it says camshaft position sensor intermittent bank 1 sensor 2. So this code description over here is pretty self-explanatory. So the camshaft position sensor on bank 1 sensor 2, but the second sensor is producing an intermittent signal. So sensor 2 on bank 1 is going to be the exhaust camshaft sensor. Okay, we have two camshafts on one bank. So bank 2 is going to have two camshafts, the exhaust camshaft and the intake camshaft. So based on this code description, the exhaust camshaft position sensor on bank 2 is putting out an intermittent signal. Okay, and this can be caused by a defective sensor or a problem in the wiring between the sensor and the ECM. We have one code in the transmission control unit. So now I'm going to scroll down. Let's see what else we have in the other control units. So this over here is pretty straightforward. This is a pretty straightforward code. So let's scroll down. We don't have any codes in these control units, so that's good. We have two codes on the generic side of the tool. So we have the same codes on the generic side of the tool, P0365 and P0369. So now what I'm gonna do is we can go two ways about this. We can go in the engine computer and look at some cam sensor data. Let's see if we can have some cam sensor data here. Let's go to engine. But if we don't have any cam sensor data PIDs, and then we can just go to the sensor and do some tests at the cam sensor itself. So we got crank sensor signal fault. So let's see if we have anything about cam sensor. So nothing here, no data PIDs. Okay, let's see. I think I saw something about cam sensor here. So cam sensor sync. Let me customize this list. Now this could be an intermittent issue because the second code said that the fault was intermittent. So if it's intermittent, we may not see the fault right now. So just FYI. So I'm interested in any data PID that says something about the camshaft. So intake cam 1, crank difference degrees. Let's see these PIDs over here. Let's see if these PIDs are even helpful. So that's it. Okay. Actually, since it's sensor 2, the code we have is about sensor 2, I'm just gonna graph the data PIDs for the exhaust camshaft. Okay, I don't want to have a lot of data on the screen. That can be a bit confusing. I'm just gonna select the exhaust camshaft data PIDs. So anything that says something about exhaust camshaft is what I'm gonna grab. I'm gonna grab my crank sensor or crank data PIDs too. Okay, so that's it. Let's list these PIDs. So right now with the key on, engine off, so cam sensor sync, out of sync. Now this is because the engine is off and the engine is now running. Okay, so I'm gonna start the engine. So exhaust cam 1, desired position, exhaust cam 2, desired position. So these two numbers are pretty much mirroring each other. Okay, so exhaust cam 1 desired position is 114.8 degrees, and then exhaust cam 2 desired position is 115.7 degrees. So that's good. Now, as I'm looking at these data PIDs here, I'm looking at values that might be way off than others. So everything looks pretty good. I'm gonna start the engine. Let's see if we're gonna see something that's gonna catch our eye here. So we are focusing on these numbers here. Exhaust cam 1 desired position, we have 108 degrees. Same thing on exhaust cam 2. So exhaust cam 2, exhaust cam 2 is the exhaust camshaft on bank 2, and exhaust cam 1 is the exhaust camshaft on bank 1. So they're both in sync. This is good. Now, if we had a timing issue, these data PIDs over here, I mean, this data would not be in sync. The fact that the crank sync says it's in sync with the cam sensors, so this is good. Okay, so crank signal missing, it says fault, so we are not missing a crank signal. So everything looks good, guys. We don't have a timing issue. The issue is most likely just a defective cam sensor. So I'm gonna turn off the engine. We're gonna go under the hood and get access to the sensor so we can do some tests at the sensor. It looks like we're just dealing with a defective sensor. So we need to figure out where bank 1 is. So let's back out. Let's look at the code again, because the code says bank 1 sensor 2. Okay, so right here, camshaft position sensor circuit, bank 1 sensor 2, camshaft position sensor intermittent. Okay, so bank 1 sensor 2, so the exhaust camshaft position sensor on bank 1. So to figure that out, we're gonna back out and let's go to guided component test. We're gonna look at our firing order so we can figure out where bank 1 is. So let's go to ignition test component. Okay, so we have some information over here. What does it say? Best test location, connector at coil. So this is telling us if we were wanting to test the coils. And then firing order, so first cylinder, so cylinder number 1, orientation, furthest cylinder from firewall on right side. So right side is going to be bank 1. So we are sitting on the driver's seat, so this is going to be the right side, and this is going to be the left side. So bank 1 is the passenger side cylinder head. So the cylinder head on the passenger side is bank 1. Okay, so now what we're going to do is, we can read about this cam sensor, but we don't have to. This is a Hall effect type sensor. So this setup is actually 2 sensors in one. So this connector over here has 4 wires. So the way this is set up is we have 2 sensors in one. So they both share the 5-volt reference and the sensor ground, and then they both produce individual signals. So let's go under the hood so we can get access to the cam sensor so we can do some tests at the sensor connector. I pulled up the engine performance wiring diagram on the scan tool. So we're gonna remove the engine cover. This cover just pops off. We're gonna get this out of the way. So here's what we got. So according to our service info, this over here is bank 1. So the passenger side bank is bank 1, and the bank on the driver's side is bank 2. So our camshaft position sensor is back here. So this is the camshaft position sensor. So this is 2 sensors in one. The exhaust sensor and the intake camshaft position sensor are housed in one unit. Okay, so if we look at the wiring diagram here, this is the cam sensor assembly on bank 1. So if we look at the wire colors, our 5-volt reference is the yellow wire, and then our sensor ground is the dark blue wire. Oops, I clicked on it. Let's zoom in. Okay, so the 5-volt reference is the yellow and pink wire, and then our sensor ground is dark blue and dark green. So dark blue with a dark green tracer, and then our camshaft signal is dark blue, so dark blue wire with a gray tracer, and then the other signal wire is dark blue and brown tracer. So the dark blue with gray is one sensor signal wire, and then this one over here, dark blue with the brown tracer, is also another sensor signal wire. So what I'm gonna do now is we can back probe all these wires so we can watch our sensor supply voltage and our sensor ground and the signal coming from these 2 sensors. Okay, so what I'm gonna do now is I'm gonna back probe all these wires at the sensor electrical connector. Since this sensor is putting out an intermittent signal, what I'm gonna do is I'm gonna get access to the electrical connector of this sensor and back probe all the wires, and then we're gonna watch the voltages out of all these wires on the lab scope. Okay, we might even have to test drive this vehicle. Hopefully we can get this sensor to act up when we have the lab scope connected to it. Okay, so I'm going to disconnect this sensor. Let me put the light over here. I'm gonna disconnect this sensor so I can connect my lab scope to the sensor wires. I undid the little red lock for the sensor electrical connector off camera. So now we can disconnect the sensor electrical connector. So just like that. So right here. So I got the sensor disconnected. So now I'm gonna back probe all these wires. I'm gonna back probe these 4 wires, and then I'll bring you guys back up. I got all the wires at the cam sensor back probed. We are using our long snap-on test drive test leads from AES Wave. I love these test leads. So now I'm going to reconnect. So here's what we got. Okay, so I got all these wires back probe at this electrical connector. I hope you can see right there. Let me bring the light down here. Okay, so all the wires are back probed, and we also have to make sure that these back probes are not touching each other. Okay, so now I'm going to reconnect the electrical connector to the sensor. So just like that, the sensor is reconnected. Okay, so we are back probing all the wires. We're good to go. So now let's go in the vehicle so we can test drive the car. We're gonna test drive the vehicle and see what kind of voltage signals will come out of that sensor when we drive down the road. I'm gonna show you the sensor on bank 2. So bank 2 is the bank on the driver's side, and the cam sensor on bank 2 is right there. I hope you can see it. I just wanna show it to you, just right here. All right, so now I'm gonna get my scan tool out of the way. So we're gonna close the hood. We have our test leads coming from under the hood, and they're going into the vehicle. So we have these long test leads over here. So now let's get in the vehicle so we can go on a test drive. Now we're gonna connect our test leads to the lab scope. Yellow one is gonna go to the yellow trace. We have our ground over here, and then the green one is gonna go over here. Now we don't have to piggyback this ground. All these channels are grounded internally, so we're good there. Okay, so we're good. We got our 4 channels connected. So now let's set up our lab scope. Let's go to scope multimeter. So I'm gonna drop this down to 10 volts. Let's be on the 10 volt scale for now. Okay, so we have our 4 channels on. So right now with the key off, engine off, we are reading about 00 on all the traces. So now I'm going to turn the key on. Let's see what we got. So the key is on. We have 5 volt on the green trace. So the green trace is our 5 volt reference. So now I'm going to start the engine. Okay, so the blue trace, it looks like the blue trace is some type of sensor signal. So I'm gonna rev up the engine. We should have 2 signals over here, but only the blue trace is producing a signal. So our 5 volt is now moving. So we know that our green trace is the 5 volt. So I'm gonna move the green trace up here. If I turn off the blue trace, we should have another sensor pulling out some activity over here. But as you can see, nothing is happening. So I can tell that the sensor is receiving good voltage. So the reference voltage is good, and our sensor ground is also good. Actually, based on what I see, it looks like our yellow trace is our sensor ground. Can you see how, oops. You see how we have 0.01 on the yellow trace, but we have 00 on the red trace, unless we're not making good connection here, but something is wrong with this red trace. So the red trace is most likely the exhaust cam sensor that's not putting out a signal. Let me turn on the blue trace again. So we should have 2 traces that should be producing a square wave like the blue trace is. So the blue square wave that we see on the lab scope screen is coming out of the intake camshaft position sensor, which is good. But the exhaust camshaft position sensor on bank 1 is now producing a signal. Actually, let's go back to our wiring diagram. So this over here is the intake cam signal wire, and then you see how it says cam signal 2. So the dark blue with the brown tracer is going to be our exhaust camshaft signal wire. So exhaust camshaft signal wire, which is now working, is the dark blue wire with a brown tracer, and I believe that's what's connected to the to the red tracer. As you can see, nothing is happening with the red tracer. I'm gonna turn off the engine. Let's go under the hood so we can check that. Hopefully our test leads didn't move. Let's go under the hood and check the connection at the camshaft position sensor electrical connector. So we are back here under the hood. Let's make sure that we're making good connection here. Let's make sure that our test leads didn't move when the engine started. So our back probing tools are still connected to the wires. Let me disconnect this electrical connector. So check this out. So everything is connected well. So I'm gonna rearrange these wires. So I'm gonna connect the first two wires, the first two test leads on the lab scope to our sensor signal wire. So I'm gonna connect the yellow trace and the green trace to our sensor signals. So we should have square wave on these two test leads. And then I'm gonna connect my red trace to the sensor 5-volt reference, and then the blue trace should be our sensor ground. Okay, I'm gonna move these test leads off camera and then I'll bring you guys back up. So that way we're gonna know, I can already tell that the exhaust cam sensor is not producing a signal, but in case you have a question, so when we go back to the lab scope, I want you guys to just remember that the green trace and the yellow trace will be our sensor signals, okay? So I'm gonna move these test leads around and then I'll bring you guys back up. I moved my test leads around. The red test lead is connected to our sensor 5-volt supply wire, and then the yellow test lead is connected to our exhaust camshaft sensor signal wire, and then the blue trace is connected to our camshaft sensor ground, and then the green trace is connected to the intake sensor signal wire. Okay, so the green and yellow will be our sensor signals, and then red is going to be 5-volt and blue is going to be sensor ground. So when we start the engine, we should have a square wave on the yellow trace and the green trace. Okay, so yellow is going to be intake sensor signal, and then green is going to be exhaust signal. Okay, exhaust cam sensor signal. So I'm going to reconnect the sensor, and then we're gonna go back in the vehicle and start the engine. Okay, so as you can see, we're connected. Let me move this. Okay, so we're connected, everything looks good. So now let's go in the vehicle and start the engine. Okay, let's go in the vehicle. So this is the last test we're gonna do before we make a definitive call. It's starting to look like this vehicle is just going to need a sensor, but we have to cover all our bases before we replace the sensor. So let's go to our lab scope